Hello everyone, this is video number 2 of the module 6 of LLM Zoomcamp. In this module, we discuss best practices, different tricks and techniques to improve our RAG pipeline. In the previous video, I give you a brief overview of the 5 different techniques. These 5 are just, we can say, the most popular. And as I mentioned before, we are not going to explore each topic in details. We will just focus only on 2 of these techniques: hybrid search and re-ranking. And this video is exactly about the hybrid search. Hybrid search is based on the combination of 2 methods: vector search and keyword search. In vector search, we use vectorization to transform our initial text into embeddings, or in other words, into a bunch of numbers. We make the embeddings of the source documents, put them into our database, and then we find the documents that have the closest distance to the user's query in the embedding space. Keyword search is more about one-to-one match over the words. So the idea of hybrid search is to combine both approaches in one pipeline. And the question is how we can do that. So we can do that in a pretty straightforward way. Basically, each search here on the retrieval part or retrieval stage produces results ranking by scores. And we can take these scores and mix them by using such simple equation. In this equation, alpha determines the weights assigned to each score, with values typically ranging between 0 and 1. So in the case of alpha equals to 1, we get this pure vector search. Otherwise, with alpha equals to 0, so our equation transforms to the pure keyword search. And that's all about the theory. Now it's time to implement a hybrid search. What we have here. So I have already launched a Jupyter notebook in my CodeSpaces environment. I also started Elasticsearch in a Docker container in a CodeSpaces also, and prepared a notebook sketch. So in this module, we are going to use code from the notebooks from the module number 3. In module 3, we cover topics related to the vector search, vector databases, vector and semantic search, and retrieval plot also about evaluation metrics and so on. And I just opened one of these notebooks, to be precise, this one, evaluate vector. So in this notebook, Alexei implemented a vector search and write also evaluation functions and calculated several metrics like hit rate and MRR. And I just copy-paste first lines of this code from the Alexei's notebook to this new notebook. Of course, I made some cosmetic changes. For example, I moved all the imports to the beginning of this notebook, deleted some useless cells, and so on. But the whole pipeline stays the same. We imported the necessary modules, then we loaded our documents with questions, answers, and documents IDs. Then we loaded model that we use to build embeddings for our documents. And finally, set up Elasticsearch settings and index our documents. So in these blocks, I guess this is the most important or most interesting part, because in these blocks we have vector search implementation by using KNN algorithm. So let's try to experiment with this part. Now we want to change this vector search in such a way as to turn it into a hybrid search. We know that we are using Elasticsearch for storing our data, for storing our documents. That's why we can directly go to the Google or maybe to the official documentation and try to find information about hybrid search. This is what I have already done. And I found a couple of pages related to hybrid search implementation in Elasticsearch. So as you can see from this page, to build our hybrid search, it will be enough just to take two parts. I mean, vector search and our standard keyword search, and put everything together in one place. In this case, the final score for each hit will be calculated the sum of the KNN and query scores. We can also specify a boost param here to give a weight to each score in our sum. So let's try to repeat this. So here we have a vector search, yeah. And for implementing hybrid search, we need to copy paste a piece of code from another notebook in module 3, where Alexei implemented just a simple keyword matching search. So this notebook called evaluate text. And here we need just this part. Let's call it keyword search. And here we have our default question, like I just discovered the course, can I still join it? Now we are going to vectorize our initial query, user's query. Now we are running KNN query. Yeah. Also, we need to add, of course, we need to add a filter here. And let me change this part by this keyword query. Yeah. We get an error. It's object after query name. Yeah. Let me check it. Cross filter. Yeah. Now I found this problem. That was because we don't need these two lines of code. Because we just need to combine KNN query and keyword query. And now, as you can see, it works. Also, what we can do, we can add these boost values to each part. By default, we can use 0.5 values. And let me check. Query to move it inside multi-match. As you can see, our scores in our search, they changed. That's all I think. We implemented simple hybrid search. Now I guess it's time to rewrite the whole pipeline. Let's call it hybrid search pipeline. Here I'm going to take code snippets from the Alexei's notebook. So what we need here, of course, we should load ground truth docs. No, from this one. So what we need also functions to calculate our metrics like rate and Marrow score. So always cells. Also, we need the Elasticsearch function. But we of course have to modify it. And we need also this evaluation function. And this question vector can. So now we are going to rewrite. We will start from the Elasticsearch kernel. Let's rename it like Elasticsearch hybrid. And here we need to put, also need to put our modified kernel query path. And also we need to add keyword query path. Yeah, I also forget to mention one important thing. I guess here we don't need to implement boosting for separate parts of our keyword search like we do in first modules. Maybe you remember that we weighted additionally, boosted additionally question part just to make sure that our search algorithm will pay much more attention to this part. But now I guess we don't need this. That's why I deleted this boosting, because now we are going to play with these boost variables just to find the trade-off between the vector search and keyword search. So let's try to add here a query path. Keyword query. And also we need to specify the size. Yeah, it's the size of the relevant answers that will return our search. Because KNN algorithm return five elements here. Also our keyword search where we return 5 elements. It would be 10 elements in sum, but we don't need to change the length of our answer. That's why we need to specify the size of our query here. And I think that's all. Next, we need to modify this question vector function. Let's call it just question hybrid. Yeah. And yeah, I forget just to change the list of params that our function Elasticsearch hybrid will take. So we need here build vector. Yeah, also we need query here because query is needed for our keyword search. And now we need to also change the call of our function here. So it should be, will stay the same. Vector, course, and we need to change query here. Would be question. Yeah. And the last thing, we need to check our evaluation function. It seems like we don't need to make any changes in our evaluation function. Now we can just call our evaluation function to run the whole pipeline and calculate our scores, our metrics, hit rate, and MRR. Also, I would like to copy paste the scores that Alexei got by calling this function using simple vector search. I just put it here. Elasticsearch. Search. Okay, and then we need to pass to our relation function ground truth and our search function that called question hybrid. Oh, such canon is not defined. Yeah. Here we need also to change the name of our function, of course. Yeah. It will take some time to calculate our scores, to run the whole pipeline. What we can do, well, while we are waiting, we of course can copy paste other functions to run it not only on questions, but also on answers, on documents answers. And also, as you remember, we built 3 types of embeddings on our questions, on our answers, and the third one was we combined, just concatenate answers with questions, and also build embeddings. So for each of these cases, we need to write the independent function. So the second one would be this one. Let's rename it text. So other params, we don't need to change them, I guess. And need to change the name of our search function. Yeah, the first calculation was finished, and as you can see, we improved our scores. The hit rate was increased by, I think, by 15%. Also, we improved our MRR score significantly. Yeah, that's great. So now let's try to run our next function that will calculate the scores using KNN under KNN over the answers of our questions. Yeah. And the last one, our hybrid search on questions and answers. Extractor. Let's rename our function. Good. Yeah. So our second run also improved our metrics, hit rate and MRR, but in a comparison with our first run, where we implemented search over the only questions. So I can say that we get better scores here. Looks like we get the same scores. Yeah, but anyway, they're better than the scores that we got using just a simple vector search. And it's finished. Now we can compare our scores with the scores that Alexei got in his notebook. Yep. And in the case number 3, where we used question answers embeddings, we got the metric values slightly better than in the previous cases, and also better than Alexei got in the module 3, the pure vector search. So it seems that our hybrid search has benefits. I'm pretty sure that's not the limit, and we can further increase our metrics by playing with these boost params, boost values. For the instance, we can increase the weight value for a KNN part, for example, and that will increase its impact on the final score. But of course, we need to carry on some additional experiments to prove this theory. So let's summarize. Hybrid search looks like a linear combination of two parts, the vector search and keyword search. In this video, we implemented Fiber search by using the functionality of the Elasticsearch. So then we borrowed the code from the Alexei's notebook, where he implemented a vector search and vector search pipeline and calculated the metrics. We slightly modified this code by adding keyword matching to the search, and then we run all these three cases for the question embeddings, for the answer embeddings, and question with answers embeddings, and calculated the metrics in each case. As you can see, we have managed to improve our metrics. Of course, I will add all these notebooks and all these links to the GitHub repo. And I think it's enough for this video. Thank you very much. See you soon.